Welcome. So we'll continue the study of differentiation rules, and we'll see two new rules in this video. So we have derivative of exponential function. It has two cases which you should pay attention on, and we see also derivative of logarithmic functions also has two cases. So case number one for exponential function. So in this case what we have is e in case of a constant. So our constant is the number of Euler. So we have wherever we have an expression of the type y is equal to e raised to u, where u can be any function, the derivative of that function is that function that is in the power, which is u in our case, differentiated and then multiplied by the original function. So what we have is u dash, which means derivative of u into e raised to u. So it does not change. The only transformation we have here is that we are differentiating the power of e. See this example. F of x is equal to e raised to 2x squared plus 6x. So they want to find the derivative of this. How do we solve this? So dy by dx is equal to f dash of x. We have to find the derivative of this function and then multiply by the original function. And to do that is, what is the derivative of 2x squared plus 6x? So in our case, n is equal to 2, and we have seen that when we have an expression such as in x raised to n, its derivative becomes something such as n raised to x raised to n minus 1. In our case, our n is 2 in this expression. So to find the derivative of this, what we do is just we put that n down, and we put an n down, which is 2. We have 2 into 2, which is 4x, and then we have x raised to 2, but because they are minus 1 over there, so it becomes 1. So as conclusion, what we have is 4x plus derivative of 6x, it's 6. All this is multiplied by e raised to 2x squared plus 6x. So basically we're just adding the derivative of the power, and we just multiply it by the original function. Just to make it beautiful, we'll write it here. Now case number 2. In the case number 2, in place of e we have another constant, a different constant that we call as a. But the thing is that the expression that has a variable is in the power again. So what we do now is find the derivative of the power, multiply by the original function that was given, and also multiply by the natural log of that constant that represented the base of that power. Look at the example. So this is the power and this is the constant in place of a. So our a is 2. Our a is 2. And our u is minus 3x squared plus x. So what we do in this case to find the derivative is derivative of u, which is the power. So the derivative of u is, this comes down, so we have minus 6x, and then we have 2 minus 1, so it's 1, plus derivative of x is 1. So we have u dash, which is minus 6x plus 1, into the original function, as we've been doing in like in the case 1, 2 into minus 3x squared plus x. Now we multiply this by the natural log of u. There's no space. So what we have is minus 6x plus 1 into 2 raised to minus 3x squared plus x, which is the u itself without any modification, multiplied by the natural log of the base, which is 2, natural log of 2. So this is the derivative. This means natural log. So now derivative of logarithmic functions. There are again two cases in the case of derivative of logarithmic functions. In the case 1, what we have is that it's a natural log, and when you have a natural log of some expression which is represented by u can be in function. So what we do is basically the derivative of that argument of the logarithm divided by the original argument of that logarithm. So look at this. Y dash is equal to u dash divided by u, which means that now we're differentiating this u that was the original argument dividing by the original argument. Look at this example. Dy by dx f dash of x. So this becomes what? Derivative of this, which is our u. We can write here our u is 3x squared minus 1. The derivative of this u, this 2 comes down, so we have 6x, because this is 2 minus 1, so that's why we have power hand here, and derivative of a constant is 0, so this minus 0. So what we have now is 6x, which is the derivative of u divided by the original argument of this log, which is 3x squared minus 1, and it's done. On the other hand, we cannot use the same logic to solve another logarithm in which the base is different from e. So in case of natural logs, we can use directly this formula, but here we cannot use. The base of this logarithm is a. A can be any constant. A is a constant and u is in any function. So this function can be in terms of whatever we're talking about. In this case, it's x, can be y, z, depending on the complexity of what we are solving. So to solve, what we do, it looks a bit similar, but the difference now is that we again do derivative of the argument, which is u, divided by the original argument, which is u, into natural log of that constant which is in the base. So derivative of u, which is the argument, divided by the original u multiplied by the logarithm of natural log of the base of that log that was given to us. See this example. So to find this, as always, f dash of x, this is going to be equal to what? Well, where is our u? Our u in this case is x squared, so our u dash is equal to 2x. So what we have now is this is going to give us 2x divided by the original u was x squared multiplied by natural log of 2, which is this constant on the base, that is our a. And this can be improved. We have 2x, and then again here we have x. So this x power 2 means that we have 2x's, one is multiplying the other one. So we can just simplify this one with one of these x's here. So we have 2 divided by x natural log of 2. And end of the problem.